In this video, we'll have 3 examples of reductions and cofunctions, and I'll show you how to simplify each of these examples using the reduction formula and cofunctions as explained in previous videos. In our first example, we have cos 180 plus theta divided by sine 90 minus theta. In our previous videos, we learned that the first quadrant can be written as 90 minus theta. The second quadrant is represented by 90 plus theta and 180 degrees minus theta. The third quadrant is 180 degrees plus theta. And the fourth quadrant is 360 degrees minus theta. We also know that all the trig ratios are positive in the first quadrant, that only sine is positive in the second quadrant, that tan is positive in the third quadrant, and only cosine is positive in the fourth quadrant. Now, let's evaluate our fraction. First, we have cos 180 degrees plus theta. This is in the third quadrant, and cosine is negative in the third quadrant. So that will reduce to negative cos of theta divided by sine 90 minus theta. Sine 90 minus theta is in the first quadrant, so all of the trig ratios are positive in this quadrant. And sine 90 minus theta is a cofunction which changes sine to cosine. So the denominator would be cos of theta. And now when I simplify, cos theta would cancel out cos theta, and I'm left with a negative 1. For our second example, we would use the same Cartesian plane as before to help us simplify this fraction. So let's start with cos 180 degrees minus theta. That is in the second quadrant, and cosine is negative in the second quadrant. So it will reduce to negative cos theta. Next, we have cos 90 plus theta. This is also in the second quadrant. And we know that cosine is also negative in this quadrant. So it will change into its cofunction of sine. But notice I have negative sine theta for cos 90 plus theta. Then in the denominator, we have sine 90 plus theta, which is in the second quadrant, but sine is positive in this quadrant. So its cofunction would be positive cos theta. And then lastly, we have sine 180 minus theta, which is also in the second quadrant. But now we don't change sine to cosine, it simply becomes positive sine theta. So notice for cos 90 plus theta, it changes into negative sine theta, and sine 90 plus theta changes into cosine theta. But for cos 180 minus theta, it remains cosine, but cosine is negative in that quadrant, and sine 180 minus theta, it remains as sine, and sine is positive in the second quadrant. Now we can see that cos theta would cancel out cos theta, and sine theta would cancel out sine theta. So I'm left with negative 1 multiplied with negative 1. And that is equal to positive 1. And for our third example, we'll still use the same Cartesian plane to help us simplify this fraction. Notice in this example, we have cos square. Now what you can do is rewrite it as cos 180 plus theta multiplied with cos 180 plus theta. So the square means that we are multiplying cos 180 plus theta with itself. And for the denominator, there are no squares, so we can simply copy it over. Now we can apply reduction formulas for each individual term. So cos 180 plus theta places me in the third quadrant, and we know that cosine is negative in the third quadrant. So that will reduce to negative cosine of theta. And the second term in the numerator is exactly the same. So that will also be negative cosine of theta. Next, in the denominator, we have cos 360 minus theta. And 360 minus theta is in the fourth quadrant. And cosine is the only trig ratio which is positive in the fourth quadrant. So this will reduce to positive cos theta. And lastly, I have sine 90 minus theta, which is in the first quadrant. And all of the trig ratios are positive in this quadrant. And sine 90 minus theta changes into its cofunction of cos theta. Notice that I'm using brackets to help me see all of the changes that I've made. It's also important to use brackets so we can see that we are still multiplying terms with one another. And now if I simplify, cos theta would cancel out cos theta, and cos theta would cancel out cos theta. So I'm left with negative 1 multiplied with negative 1. And that is also equal to positive 1.